Welcome to the e-learning package on the transformation of graphs. This is part 3 of the e-learning package, Reflections. Compare these two graphs. Y is equal to x squared plus 1 and y is equal to negative of x squared plus 1. Also have a look at y is equal to x cubed plus 1 and y is equal to negative of x cubed plus 1. Take a moment to sketch these using your graphing calculator now. The first part should give you two graphs that look something like this. This is y is equal to x squared plus 1, and this is y is equal to negative of x squared plus 1. Similarly, the second part should give you this, where this curve is y is equal to x squared cubed plus 1, and this one is equal to y is equal to negative of x cubed plus 1. How are these graphs related? If you look at both of these, they are clearly mirror images of one another, x squared plus 1 and negative x squared plus 1. You can see that they're reflected along the x-axis. If you look at this one as well, you can also see that there's a reflection, where every point is mapped to another equally opposite point along the x-axis. Is this a general rule? Well, what do we say? We say that the graph of negative of x squared plus 1 is obtained by reflecting y is equal to x squared plus 1 along the x-axis, or in the x-axis. Similarly, the curve of y is equal to negative of x cubed plus 1 is a reflection of the curve y is equal to x cubed plus 1 in the x-axis. It can be generalized in the following way. The graph of y is equal to negative of f of x is a reflection of the graph of y is equal to f of x about the x-axis, or in the x-axis. So this is how we would reflect an x. You can also think of reflection as a special type of scaling, a scaling with a negative scale factor. We will cover this and look at a demonstration momentarily. Before we do that though, let's take a look at example 14. Compare the graphs of x cubed plus 1 and negative of x cubed plus 1. You can see that these graphs this second graph just replaces x with negative x. What happens? It gives us this curve where the dark line is y is equal to negative x cubed plus 1 and the normal line is y is equal to x cubed plus 1. What's happened? Well, they're not reflected about x, about the x-axis, because you can see this point doesn't reflect to anything down here, but they are reflected instead this time about the y-axis, that every point has its opposite on the opposite side of the y-axis. So we say that the graph of negative x cubed plus 1 is obtained by reflecting the graph of y is equal to x cubed plus 1 in the y-axis. This can be generalized by saying that the graph of y is equal to f of negative x is a reflection of the graph of y is equal to f of x about the y-axis. And again, we can think of this reflection as negative scaling. What do I mean by negative scaling? This is a GeoGebra worksheet. What you see here is the graph of y is equal to a times f of bx. For your interest here, the function shown is y is equal to x take 2, x plus 2. What happens if I increase the number out the front? We learned about this in the previous section. We know that this will scale along the y-axis, or parallel to the y-axis. And I can do that going for a number bigger than 1, that will make it bigger. If I go to a number between 1 and 0, that will make it smaller, it will compress it. But what happens if I keep going past 0? Then the graph flips. So in this sense, we can think of reflection as a special type of scaling, where we've just gone past 0. So that works very nicely for the y-axis. Does it also work for the x-axis? Well, if I increase this, what happens? It gets compressed, but it's never going to flip, is it? But what happens if I stretch this out? As I move b closer and closer to 0, well, we know the graph is going to get more and more stretched out. When it hits 0, it's flat, and then it reflects about the y-axis when b is less than 0. So we can see that again, it's a special type of scaling where I've flipped it about the y-axis. So, by way of a summary, if we have a negative sign outside our function, it will flip the entire function. It flips the entire graph along the x-axis, or the line y equals to 0. If the negative sign appears inside our function, then it will flip the graph along the y-axis. You may want to test your understanding by trying this challenge question. Thank you for participating in this e-learning. I hope that you have found it a fruitful and valuable exercise. If you have feedback that you'd like to give, please approach one of your tutors who would very much enjoy hearing what you thought of this e-learning package. If you have questions from this, also please approach your tutor or the lecturers after lectures resume. Thank you. Goodbye.